Good morning, class! How are you today? Oh, you are all doing good? Okay. May I know who is absent today? No one? I like that you are very active in my class. Are you ready for our new lesson? You are ready? Okay. Who among you know Gauss? Anyone? If you want to know Gauss, his full name is Johann Friedrich Karl Gauss. He was a German mathematician and he is widely regarded as one of the greatest mathematicians of all time for his contributions to number theory, geometry, probability, probability theory, geodesy, planetary astronomy, the theory of functions, and potential theory, including electromagnetism. Now, let's talk about Gauss and non-Euclidean geometry. The triumph of Euclidean geometry. By the early 1800s, Euclid's Element, 13 books of geometry, had dominated mathematics for over 2,000 years. In fact, people did not speak of Euclidean geometry. It was a given that there was only one type of geometry and it was Euclidean. The elements had been built on 5 postulates. In other words, 5 things that were assumed to be true about geometry. For example, all right angles are equal to one another. The 5th postulate of Euclid was the parallel postulate. Euclid considered a straight line crossing 2 other straight lines. He looked at the situation when the interior angles add to less than 180 degrees. In these circumstances, he said that the 2 straight lines will eventually meet on the side of the 2 angles that add to less than 180 degrees. As you can see on figure A, when each angle is 90 degrees, the lines are parallel. And figure B, if one or both of the angles is less than 90 degrees, the lines will meet. Most but not all of Euclid's geometry could be built without the parallel postulate. Mathematicians, feeling there was something disconcerting about this postulate, had long hoped to prove it using Euclid's other postulates as a starting point, but had failed. That's why Gauss stated that Euclid's way is not the only way. Probably Carl Friedrich Gauss was the greatest mathematician in history. He realized that alternative two-dimensional geometries are not possible that do not satisfy Euclid's parallel postulate. He described them as non-Euclidean. Gauss thought about a curved two-dimensional surface like the surface of a globe, mapping our planets, oceans, and continents. As you can see on the photo, the vertical lines of longitude all make angles of 90 degrees with the equator on the globe's surface. Yet by the time they reach the poles, they have met. So the parallel postulate is incorrect on curved surfaces. Gauss realized that self-consistent non-Euclidean geometries could be constructed. He saw that the parallel postulate can never be proven because the existence of non-Euclidean geometry shows this postulate is independent of Euclid's other postulates. Because of that, Gauss decided not to publish any non-Euclidean geometry. Later, this led to problems with his best friend. Farkas Bolyai was a mathematician. He had been Gauss' best friend when they were students at the University of Göttingen in Germany. Afterwards, they had stayed in touch, regularly exchanging letters. Bolyai's son, Janus was also a mathematician. In 1832, Janus published his brilliant discovery of non-Euclidean geometry. His father enjoyed that his son might have achieved something worthy of praise from Gauss, the man he admired more than any other. Asked Gauss for his view of the work. Gauss replied that he couldn't praise the work because in doing so he would be praising himself. Janus had merely published work that Gauss had done privately long ago. Needless to say, Gauss' reply to Bolyai went down like a lead balloon. The Bolyai's belief Gauss was trying to steal the discovery, which he wasn't. He had no intention of publishing. So Janus Bolyai received full credit for his discovery, as did Nikolai Lobachevsky, who discovered it independently. Whether Gauss actually fleshed out non-Euclidean geometry as comprehensively as Bolyai and Lobachevsky is uncertain. Why did Gauss not publish non-Euclidean geometry? Gauss made many more discoveries than he published, right? He liked to release his discoveries to the world as perfect mathematical jewels with all signs of mining, rough working, and polishing removed. His ideas and insights were so abundant that he did not have time to polish them all for publication. Also, if he felt his work was too far ahead of its time and would provoke controversy, such as his non-Euclidean geometry work, he would not publish it. His attitude was that he did not wish to waste his precious time engaging in pointless arguments with people who were incapable of ever fully understanding his work. So that's all for today. I hope you learned about Gauss, and see you next meeting. Goodbye!